Hello students, now we are going to start worksheet 2 of chapter 3, rational numbers as decimals. So before starting worksheet 2, come on page number 52. Here, see the topic, conversion of rational numbers into decimals by long division method. So we are going to start long division method. See like this, we have to do divisions. Okay, so under this topic we have terminating decimals and non-terminating decimals. Okay, so what are terminatings? Here if we see in this division, we get the remainder as 0. So whenever the remainder gets 0, the answer here stops. So this is known as terminating decimals. Okay, the remainder is 0, so answer is this 0.625. Further we don't divide then when the answer gets, so when the remainder gets 0. Okay, so this is known as terminating decimals. Okay, and in non-terminating we never get the remainder as 0, it goes on continuing. So the answer also, the quotient also goes on it continues. Okay, so see 0.333, it will continue because we are not getting the remainder as 0. So this is known as non-terminating decimals. On the next page also you can see, here we can see when 2 divided by 7, again here remainder is not 0, it is continuing. See again 2, we are getting remainder as 2. So the answer continues. Okay, so this is also non-terminating decimals. So we will understand this terminating and non-terminating decimals more when we start the worksheet. So let's start the worksheet. Okay, so worksheet 2, question number 1, express the following rational numbers as decimals by using long division method. Okay, so we have to divide this rational numbers and convert it into decimals by long division method. So let's start. So we wrote the question 21 upon 16. So we have to convert this into decimals by using long division method. Okay, so we will start. So inside the numerator we write it inside and the denominator we write as the divisor. Okay, so let's start. Now 16 ones are 21, so 16 ones are 16. Okay, so 21 minus 16 is what? 5. Okay, now 5 is smaller than 16, we cannot divide, so we will give here point. Okay, decimal, so we will get here 0. So when we give decimal, next we get what? 0. Okay, so now 50. So 16 3s is 48. 16 3s are 48 minus, so 50 minus 48 will gives us 2. 15 minus 48 is 2. As we have already given the decimal, here it will come what? 0. Okay, now 20. So 16 ones are 16, 16 2s is what? 32. So 32 is bigger, so 16 ones are 16. Again 20 minus 16 is what? 4. Okay, so already we have given here decimal, so here it will come 0. Okay, so now 16 ones are 16, 16 2s are 32. Right, now subtract. Now 40 minus 32 is what? 8. 40 subtract 32 will get 8. Already decimal is given, so here it will be 0. Okay, now 16 5s is 80. Okay, so subtract 80 minus 80, zeros. Now here we got the remainder as 0. Okay, we see we got remainder as 0. So here it terminates, the answer stops over here. Okay, as we got 0 in the remainder. So what we will write? 21 upon 16 is equal to, what is the answer? 1.3125. So 1.3125, and this is a terminating decimal. We are not going to write here because they have not asked in the question whether it is a terminating or non-terminating decimal. So we will write only this much. 21 upon 16 is equal to 1.3125. We have converted this rational number into decimal. Okay, so next question we will write 1.2, 129 upon 25. Okay, So let's divide. 129 is the numerator, so we write it inside. Okay, and the denominator we will write it outside. Now 129, so 25 5 is 125. If you don't know, so you can do it in the rough column. So 25 2s are 25 3s are 25 4s are, so 25 5s if we do 5 5s are 25, 5 2s are 10 plus 2 12, 125. You can do it in the rough column. Okay, so 25 5s are 125. So what we get? 4. 9 minus 5 4, this 0. Now 4 is smaller than 25, so what we'll do, we will give the decimal point. Okay, so when we give the point, we here it what we get? 0, so it becomes 40 now. So now 25 ones are 25, 25 twos is 50, 50 is bigger, so 25 ones are 25. Subtract. Now what we get here when we subtract? 15. Here 10, 10 minus 5 5, cut 3, 3 minus 2 1. Okay, 15 we get. Now already decimal point we have given, so here 0 comes. Okay, so 150. So 25 6 if you see, it is 150. Okay, 0 0. So what we get? A remainder as 0, so it terminates over here. So what is the answer? 5.16. It doesn't continue. Okay, so 129 upon 25 is converted into decimal as 5.16. Okay, this is a terminating decimal. Okay, now next 17 upon 200. Okay, so let's start. 17 as the numerator we write inside, and 200 denominator we will write it outside. Okay, so now if we say 200, 17 is smaller than 200. So what we'll do, we'll write 0. Let's say how it comes? 200 zeros are 0. So 17 will come down. So instead of that, what we'll do? 0 and point we'll give. 0 and decimal point. So when we give 0 and decimal point, directly 0 will come here. Okay. So it becomes 170. Now again 170 is smaller than 200. So again we'll write 200 zeros are 0. 0 into 200 will get what? 0 only. 0 into 200 will get 0 only. Okay, so 200 zeros is 0, minus subtract, we get 170 again. Okay, and we have given already the decimal point, so here 10 comes. Okay, so now it is 1700, 1700. Now if we see this is 200, so only 2, so we can count the table of 2 also. 2 ones are 2, 2 twos are 4, so 17. So 2 8s are 16 we get, right? 2 8s are 16. Here I will write 2 8s are 16. Okay, so 2 8s are 16. So 200 into 8 also 1600. So 2 8s are 200 into 8, we will get 1600. Okay, got it? 2 8s are 16. So 200 into 8 also we do. 2 8s are 16, and this 2 zeros 1600. Same we have done here. Okay, so when we subtract, we get what? 100. This 2 0 subtract, 7 minus 6 1, 1 minus 1 0. So we got 100 here. Now decimal point already we have given, so we'll get one more 0 over here, so we get 1000. Now if we see 2 table, 2 5s are 10, right? 2 5s are 10. So same again we will do 200. We want what? 200. 200 into 5, we get 2 5s are 10, and these 2 zeros 1000 we get. So here 1000 is there. So 200 into 5, we get 1000. Minus we do, we get 0. Okay, so it terminates over here, we get 0, it ends over here. Okay, so what is the answer? 0.085. So I will write 17 upon 200 is equal to 0.085. Okay, this is also terminating decimal. Okay, next question. 5 upon 11. Okay, so again the numerator 5 we will write inside, and the denominator 11 we will write outside. Okay, now again 5 is smaller than 11, so what I will do? 0 point. So 0 point, I will write decimal point, I will get 0 over here. So it becomes 50. Now 11 ones are 11, 11 twos are 22, 11 threes are 33, 11 fours are 44, 11 fives are 55. 55 is bigger number. So I will write 11 fours are 44. So 50 minus 44, I will get 6. Okay. Now again decimal point we have given, so 0 will come here. 60. So 11 fives are 55 I will write, because 11 sixes is 66. 66 is greater than 60. So I will write 11 fives are 55. Now we subtract, what we get, 60 minus 55, 5. So again point is there, so we give here 0. Now see, 50 already it was here, again it came. So what I will do, again 11 fours are 44 I will get, right? So when we subtract 50 minus 44, again I will get 6. So decimal point is there, so I will, here it will be 60. So again 60 is same, 50 again repeated, 60 is also again repeating. So if I write 11 fives are 55, again I am getting what? 5. 60 minus 50. See, again it is repeating 3 times. Again 5, 50, 50, and here also 50 is repeating. So now this answer is repeating, and I am not getting remainder as 0. It's repeating 50. See, after here 50, this is repeating here. Then 60 is also repeating. Again 50 is repeated. Again 60 will repeat. I am not getting 0 as the remainder. And here the answer is repeating 4, 5, 4, 5. It will continue then. So this is non-terminating decimal. Okay. It keeps on repeating. It's not ending. Okay. So what I will write, but I will stop here. We won't continue. Na? So 5 upon 11 will write, and so what is the answer? 0.45. Only one time we will write. We won't write 0.454545. Okay. So we will write 0.45 and we will put a line on that. Okay. This means this 4, 5. This both the numbers 4, 5 and 4, 5. These are continuing. Na? So it means 4, 5 are in continuous. Okay. They are continuing. Got it? So this is a non-terminating decimal. Okay. Now next 1.5. 22 upon 7. Okay. So again I will write 22 the numerator inside and 7 denominator outside. Okay. Now let's start. 7 ones are 7, 7 twos are 14, 7 threes are 21. So 7 threes are 21. Now when I subtract 22 and 21 I get 1. So 1 is smaller than 7. So I will put a decimal point. So I will get 0 over here. Okay. Now 10. 7 ones are 7, because 7 twos is 14. I will take 7 ones are 7. So 10 minus 7 is what? 3. As decimal point is given, we will get 0 here. Right. So 7 fours I will take 28. Okay. 7 fives are 35. 35 is bigger, greater number. So I will take 7 fours are 28. 30 minus 28 we get 2. Okay. We continue doing all this if till we get 0, or if we are not getting the repeating number. Now here say 2 is there, I am getting 2 also here, but as point is there I am getting 20. I am not getting this 22. It is 22 over here and it is 20. So until we get 22 or 10 or 30 repeating, then we will stop. Okay. Till now it's not repeating. Okay. So 20 I got. Now 7 ones are 7, 7 twos are 14, 7 threes is 21, 21 is greater. So I will take 7 twos are 14. Now 20 minus 14 is what? 6. We subtract 20 and 14, we get 6. Again decimal point is there, so we will give here 0. 60 is not that yet repeated. Okay. So further we will do 7 8s are 56, because 7 9s is 63. 63 is greater. So we will take 7 8s are 56. So 60 minus 56 is what? 4. Okay. So here we have not got 4 yet. So we will continue. Now decimal point is there. So we will give here 0. Okay. So 7 5s are 35, because 7 6s is 42. 42 is greater. So I will write 7 5s are 35. Okay. I will just do it. Okay. 7 5s are 35. Now 40 minus 35 is what? 5. Okay. Again here decimal point, so 0 will come. Okay. Now 7, what I will take? 7 sevens are 49 because 7 8s is 56. 56 is greater than 50, so I will take 7 sevens are 49. Okay. Subtract 50 minus 49 is what? 1. 1 I get. So decimal point is there, so I will give here 0. Now 10 I got. Okay. So here if we see 10, see it's repeating now. 10 I got again. So it will again repeat. I will write 7 ones are 7. Okay. What I will write? 7 ones are 7 again. So again from 1, see this 1, it will start repeating again. Now 10 10. So here it ends. One time I'll write 7 ones are 7. So 10 minus 7 is what? 3. See again this 3 is repeating 30. It will become, this will repeat, right? Okay. So we will stop here, and this number 1 4 2 8 5 7 will start repeating here again. Okay. So what the answer we will write? 22 upon 7 is equal to, see now we will write this thing, 3.14285 and for whole this I will put this line. Okay, got it? So this is the answer, and this is a non-terminating decimal. Okay, next one more thing, this line what we give up, we say it as a bar sign. Okay, now next, so we wrote the question 31 upon 27. Okay, so 31 numerator we will write inside and the denominator we will write outside. Okay, so now 31 is bigger than 27, so 27 ones are 27. When we subtract 31 minus 27, we get 4. Now 4 is smaller than 27, so we will give a decimal point. So here 0 will come. It becomes 40. Now 27 twos is what? 54. 54 is greater than 40. So I will write 27 ones are 27. Now 40 minus 27, what we get? 13. See, 10 minus 7, 3. 3 minus 2, 1, 13. 13. 13 is smaller than 27. So decimal point we get 0 over here. 130. Now 27 fours are, see, 7 fours are 28. 2 fours are 8. Plus 2, 10, 108. Because 27 fives are, 7 fives are 35, 2 fives are 10, 135. 7 fives are is what? 135. 135 is greater than this. So we will take 27 fours are 108 and we subtract. So when subtract we get what? 22. 10 minus 8, 2, 22 we get. Okay. So now again 22 is smaller than 27. So decimal point we get 0 over here. Okay. So if you multiply 27, 8 is 216. Okay. Now 220 we subtract to 16, what we get? 4. Okay. Now decimal point, so we'll give 0 here. Now 40, see 40 is again repeating. It was 40, it is repeating. So again this 148 will start repeating, right? 27 ones are 27, again we'll write. So we get 13. So again 0, 130 will get repeat. So it started repeating now. Okay, so what is the answer now? We will write 31 upon 27 is equal to, see, 1.148 we will write. Okay, so 1.148 and we will draw a bar sign over this. Okay, on 148. Right. Now next question, 1.7. 2 upon 15. So again 2 numerator we will write inside and 15 denominator will write outside as divisor. Okay. Now 2 is smaller than 15. So what we will write? 0 and decimal point in the quotient. So here we will get 10. So 20 is now bigger than 15. So 15 ones are 15. 20 minus 15 is what? 5. So as decimal point is there, we will get here 0. It becomes 50. So 15 ones are 15, 15 twos are 30, 15 threes are 45. 45 we will do because 15 fours is 60. 60 is greater than 50. So 15 threes are 45. Okay. Now 50 minus 45 is what? 5. Again we got 5. So decimal point is there, so we get 0. Again we will write 15 threes are 45. 50 minus 45 is what? 5. Again see, 3 times it is repeating. So it will go and continuing. Again 0 will come, again it will repeat. So this 3 is repeating. See, this 3 is repeating. 1 is not repeating, 1 is like that only. Only 3 is repeating. Okay, so how we will write? So this is also non-terminating decimal. So I will write 2 upon 15 is equal to, see, 0.1. Okay, 1, and 1 time 3 will write, and only upon the 3 we will give the bar sign. This means only the 3 is repeating, not 1. Okay, this much. So this is what? 0.13333. Okay, repeating, non-terminating. Got it? Okay. Now next question, 1.8, 63 upon 55. Okay, so again numerator 63 we will write inside, denominator 55 we will write outside. Okay, so 63 is bigger than 55. Again 55 ones are 55. So when we subtract, 13 minus 5 is 8. 50. We get 8. 63 minus 55, what we got? 8. Now 8 is smaller than 55. So what will give? Decimal point. So we'll get 0 over here. Okay. So 55 2s is what? 110. So it is bigger than 80. So we'll write again 55 ones are 55. Okay. So what we get? 5, 25 we get. Okay. So again 25 is smaller than 55, so the decimal point we get 0 over here. Okay. Now next 55 4s if we do, so we get 220. 55 4s, 4 5s are 20, 4 5s are 20 plus 2, 22. 220 we got. So when we subtract, 5 minus 2, 3, 30 we get. Okay. Again 30 is smaller than 55, so decimal point we get 300. Okay. So now 55 5s we will try. 55 5s, 5 5s are 25, 5 5s are 25 plus 2, 27, 275. So 55 5s what I will write? 275. So when we subtract this 10 minus, here 10 it becomes 5, 9, 25 we get. Okay. We subtract 300 minus 275, what we get? 25. Again point is there, so 0 will come. See, again 250 I got. Same. So again we'll write 55 4s are 220. Okay, so what we get? 30. Again 0 will come, so we'll write 55 5s are, sorry, 55 5s are 275. Right? So again 25 we will get. 1 minute. So this is going on repeating. See, 250, 250 got repeated. 300, 300 got repeated. Again here 250 will come. So this is also a non-terminating decimal. And what is here repeating? See, 1.1 is there, but only 4 and 4, 5 and 4, 5 are repeating. Okay. So how we will write? The answer, 63 upon 55 is equal to 1.1. 4 5 is only repeating, so upon the 4 5 only we will give the bar sign. Okay, not on the 1. So we have completed question number 1 of worksheet 2. Okay, now we will start question number 2 of worksheet 2. Okay, without actual division, determine which of the following rational numbers have a terminating decimal representation and which have a non-terminating decimal representation without actual divisions. It means previously we have done this long division method. So without doing this division method, directly from the question we have to tell whether this is a terminating or non-terminating decimal. Okay, so let's start. So first question is 2.1, 11 upon 4. Now here in this the denominator plays an important role. Okay, so we'll start. We have to take out the prime factor of the denominator. Okay, now here what are the prime factor of 4? What is the denominator? 4. So how to take this prime factor 4 we will write. So what it is, 2 into 2 is a 4, 2 1s are 2. So what I got, 2. 2 into 2 I got. Okay. So whenever you get 2 or 5, what? 2 or 5. Whenever you get 2 or 5 as the prime factors, though then we say it as a terminating decimal representation. But other than 2 and 5, in other numbers you are getting like 3, 11, whatever. So then it is a non-terminating decimal representation. So here what we got, 2. So what we'll write? The prime factor of what, 4? Of 4 is 2. What is the prime factor of 4 is 2. 2 we got. Therefore, 11 upon 4, okay, the question I wrote, has a terminating decimal representation. Okay, representation. When it is terminating, when the factors what we get of the denominator are 2 and 5, 2 or 5, that time it is terminating decimal representation. Okay, now let's see the next sum. Okay, so we wrote the question 13 upon 80. Now here again, not by long division method, just by seeing, like taking out the prime factors of the denominators, we have to tell whether it is terminating or non-terminating. So we start like here, what is the denominator? The denominator of 13 upon 80 is 80, right? What is the denominator? 80. So we will take out the prime factor of that. So start with 2. 2 4s are 8. 2 zeros are 0. 2 2s are 4. 2 zeros are 0. 2 1s are 2. 2 zeros are 0. 2 5s are 10 and 5 1s are 5. So these are the factors we got. Okay. So 80 we will write, only the denominator we have to find. Okay, prime factors. So what we got? 2 into 2 into 2 into 1 2 3 4 times we got into 5. Okay, so only 2 and 5 is there. So previously also I told you 2 or 5 is there, then they are terminating decimals. Okay, so here also what we got, 2 and 5 only is there. Okay, so what we will write? The prime factors. Now we have two factors, 2 and 5. Okay, the prime factors of 80 are 2 and 5. Okay, 2 and 5. Therefore, 13 upon 80 has a terminating decimal representation. Okay, so we have completed this question. You got it? In the prime factors of the denominator we must get 2 or 5. Other than, if any other number is there, so it is a non-terminating decimal representation. Okay, so now let's see the next question. Now next question is 15 upon 11. Again, how we will write? The denominator of 15 upon 11 is what? Denominator is 11. Now what is the prime factor? 11 itself is a prime number. So what we get? Only 11 only we get. Okay, 11 is equal to 11 into 1. Okay, see, 11 ones are 11. So 11 into 1. So what we will write? The prime factor of 11 is 11. Therefore, 15 upon 11 has a non-terminating decimal representation. Okay, got it? So only 2 and 5 is there, that time only it is terminating decimal representation. Got it? Next question. Okay, now we wrote the question 22 upon 7. Now we'll already, I have written the denominator of 22 upon 7 is what? 7. 7 is the denominator. Same here, when we take the prime factor, 7 ones are 7. Only 7, because 7 is a prime number. So what are the factors? 7 into 1, right? So what we'll write? The prime factor of 7 is 7. Okay. So 22 upon 7 has a non-terminating decimal representation. Okay. Now next. Okay, next question is 29 upon 250. Now here the denominator of 29 upon 250 is what? 250. So we have to take the prime factor. Okay, so goes in 2 table. 2 ones are 2, 2 twos are 4, 1 carry, 2 fives are 10. Now this goes in 5 table. 5 ones are, sorry, 5 twos are 10. 12 is there. So 5 twos are 10. 2 gets carry. 5 fives are 25. 5 fives are 25. 5 ones are 5. So what we got? 2. For 250 we got 2 into 5 into 5 into 5. So here we got only 2 and 5. So whenever we get 2 or 5 or 2 and 5, whatever. So it is a terminating decimal representation. So we will write the prime factors of 250 are 2 and 5. Therefore, 29 upon 250 has a terminating decimal representation. Okay. Now next question. Now 37 upon 21, next question. The denominator of 37 upon 21 is what? 21 is the denominator. So we'll take out the prime factor. 21. Now 21 goes in 3 table. 3 sevens are 21. 7 ones are 7. So which are the two factors? 3 and 7. So what we write? 21 is equal to 3 into 7. Okay. Here we don't have 2 and 5. Okay. So what we'll write? The prime factors of 21 are 3 and 7. And what we require? 2 and 5. Okay. So these are not 2 and 5. So therefore 37 upon 21 has a non-terminating decimal representation. Okay. Next question is 49 upon 14. Now here see the denominator is 14, but if we take out the prime factor of 14, what we will get? 14, 2 sevens are 7 ones are 2 and 7 we get for 14, right? But before doing that, if we see 49 and 14, they are going in same table of cells. They are going in 7 table. Okay. So we have to reduce these numbers. Okay. We have to bring these numbers in the lowest form. So if we see the previous numbers, like see 37 and 21, they were not going in same table. Previously also whatever we have, the questions we have done, 29 to 50, 20 to 7, they were in their lowest forms. Okay. But here see 49 and 14, they are going in 7 tables. So if we if we reduce this to its lowest form, we get 7 sevens are 49, 7 twos are 14. So what is the lowest form we got? 7 upon 2. Now we will take this as the rational number, from where we will determine it is a terminating or a non-terminating. So now here what we will write? Okay, so the denominator of 7 upon 2 is 2. Now we will consider this 2. So what are the factors of 2? 2 into 1. Okay, so what we will write? The prime factor of 2 is 2. Therefore, this becomes, it's only 2. This becomes a terminating decimal representation. So, we will write now the main question, 49 upon 14. So, 49 upon 14 has a terminating decimal representation. So, it is a terminating. Okay. So, what we did, 14 upon 14, we brought it to its lowest form. So, we got the question as 7 upon 2. So, the 2 denominator, we got the prime factor. So, we got what? 2 as the factor of 2. Okay. So, when 2 or 5 comes as the factor of the denominator, so it is a terminating decimal representation. And here we'll write the original question. Okay. Now, next sum. Now, next question is 2.8, 126 upon 45. Again, if we see, we can bring this number to the lowest form because 126 and 45 go in 3 table. So, keeping 3 in mind, 3 4s are 12, 3 2s are 6. Keeping 3 in mind, 3 4s are 12, 3 2s are 6. And here 3 1s are 3, 3 5s are 15. Okay. Again, these 2 are going in 3 table. So, 3 1s are 3, carry 3 4s are 12, 3 5s are 15. Now, 14 upon 5 are in the lowest form. Okay. So, what we will write? The denominator of 14 upon 5 is 5 because we have brought this number into the lowest form. So, now the denominator is what? 5. So, what are the factors of 5? 5 into 1. So, now next, so it becomes a terminating decimal representation. Okay. When you have 2 and 5 as the factors, it is a terminating decimal representation. So, next step. Okay. So, the prime factor of 5 is 5. 5 is the prime factor. Therefore, the question will write 126 upon 45 has a terminating decimal representation. Okay, so we completed question number 2 of worksheet 2, and without the long division method, we can say whether this rational number is a terminating or a non-terminating decimal. Okay.